first thing we're going to do is measure out 1 tablespoon each of the dry ingredients using this half tablespoon measuring spoon. Okay, so hello, this is our citric acid and baking soda experiment. The first thing we're going to do is measure out 1 tablespoon each of the dry ingredients using this half tablespoon measuring spoon. So it's going to be two scoops from each of these. So we're going to do that. This is the citric acid right here. Good, nice and even. Second one. Alright. Got the baking soda. Now we have all the dry ingredients together. Next thing we're gonna do is we're gonna add some of the water.
And this is hot water.
So what we're looking for here is we're gonna try to see what the reaction looks like with the hot water. As you guys can see, it is bubbling a little bit. It does feel a little bit cold. It's not super cold though. You can see a lot of the mixture is honestly still pretty dry, but it is foaming up now, almost like soap. I don't know if you guys can see, but yeah, over here it's much colder than. Over here, I'm assuming that's because the water has not reached this area yet, but yeah, pretty cold. Not a lot of precipitate or bubbles or foam or anything though, compared to what we expected with the hot water.
Now we're going to do the second trial of mixing boiling water with baking soda and citric acid. First, we're going to take 2 spoons of citric acid and put it in the bag. And then we're going to take 1 spoon of baking soda.
There's 2.
2 spoons of baking soda. And put it in the bag. And then now we're going to use boiling water and mix it in the bag.
Really?
We're going to mix it in the bag. Just 1 spoon. As you can see, it's bubbling and it's foaming up like when you wash your hands with soap. Yeah, and at the bottom there's like chunks of the mixture of baking soda and citric acid.
And there's parts where it's warm, right?
Yeah, there actually is parts where it's warm and parts where it's really cold.
Yeah, like over here in the corner it's very warm. But over here it's actually very cold.
This is probably because it wasn't really mixed that well. And
who's gonna just need a bit of peace and quiet from your incessant yapping.
But overall, it seems to be still pretty cold. This is our first test, so we're not sure what the cold water or the room temperature water would look like. But yeah. That's the second trial.
now we're gonna do the second trial of mixing boiling water with baking soda and citric acid. First, we're gonna take 2 spoons of citric acid and put it in the bag. And then we're going to take 1 spoon of baking soda.
There's 2.
2 spoons of baking soda. And put it in the bag. And then now we're gonna use boiling water and mix it in the bag.
Really?
We're gonna mix it in the bag. Just 1 spoon. As you can see, it's bubbling and it's foaming up like when you wash your hands with soap.
What? Bro, what are you talking about, man?
Yeah, and at the bottom there's like chunks of the mixture of baking soda and citric acid.
And there's parts where it's warm, right?
Yeah, there actually is parts where it's warm and parts where it's really cold.
Yeah, like over here in the corner, it's very warm. But over here, it's actually very cold.
This is probably because it wasn't really mixed that well, and
But overall, it seems to be still pretty cold. This is our first test, so we're not sure what the cold water or the room temperature water would look like. But yeah. That's the second trial. Okay, so the next trial we're gonna do is with the cold water. It's over there in the green bottle.
this is the cold water.
Yeah, we put it in the freezer for a little bit. Not enough to where it froze, obviously, but just the first cold. So we're gonna do the same thing, of course, same amount, approximately. So 2 scoops of each of the dry ingredients here.
Each spoon is 1/2 tablespoon.
Yeah, so if you want to recreate this, probably could. Okay. So same deal. 2 tablespoons total of dry ingredients. And now we're just gonna make sure that we can fill this with our cold water, and we're gonna see how much of a difference that makes in the reaction.
10 hours later.
Just give it a second.
Alright, so
Preetham did not fill the water bottle all the way.
my bad, guys. My bad, chat.
As you can see, honestly, it looks like there's not as much foaming going on here. It's mostly staying solid. It's actually quite... I don't know if it's just not mixing properly or what, but I think you can tell that there's a lot less foam here. I'll try to keep mixing it. But, yeah, it looks to be a lot less foam. As you can see, it's mostly just there's some foam over here, but over here it's still kind of just chunky and powdery, and it's not extremely cold. And I'm noticing it is around as cold as the other reaction that we did, but it was less violent, which I think is the difference between the cold water and the hot water. Obviously the hot water has a lot more energy, and so that's just more energy going into the reaction.
I totally agree.
Yeah, so it's interesting though, because you'd think that a reaction that creates, a colder temperature would benefit from having a colder ingredients, but I guess not. So, yeah, a lot less foam, as you can see here. You actually have...
This is the comparison from hot water and cold water.
Yeah, and as you can see here, this is almost all foamed down. It's not a lot of remaining precipitate. Most of it is foam and bubbles. Whereas here, this bottom left, almost like everywhere right for you guys, or left for you guys, right for me, is not dissolved in full. So it's quite interesting. We'll see if we get the same result from the second test with cold water. But yeah, very interesting.
Yep. This is trial 2 of mixing baking soda and citric acid with cold water. This water has been in the freezer for 30 minutes. So first, I'm gonna take 2 spoons of baking or citric acid and put it in the bag.
Remember, these are half tablespoons, so in total 1 tablespoon. And obviously, we want to keep our variables the same if we're not going to be changing them.
Yeah.
So baking soda right there.
And then 2 spoons of baking soda. And for our safety precaution, we are using safety goggles. Yep. To keep our eyes safe.
Yeah, very important for a lot of things, especially perhaps analyzing salts as part of a chemistry.
Yes,
final.
analyzing salts, you need to use eyes, everything. Now we're gonna use 1 spoon of cold water. And put it in the bag. Mix it in the bag. And in the observations that there's really less like foam compared to the hot water, and there's more of the solvent or solution at the bottom of the bag.
I think you can keep that out.
Keep it. When there's more of the mixture, it's more warmer, and when there's less of the mixture, it's colder. Probably because I use colder water and it's mixing with it, but don't worry about that. And yeah, comparison, this is when we use hot water, and this is when we use cold water. You see that's more, filled with foam compared to this one, where it's just barely there.
Yeah, I think that may have something to do with the energy level of the water that we're using.
The boiling water has more energy because the molecules and particles are moving faster than the particles in the cold water. Sign off.
Okay, we're going to be repeating the experiment lastly with the control. That's the room temperature water. So we're going to see if there's any kind of middle ground for the room temperature water compared to the hot and the cold water that we just used. So
Other controls is that we are in the same location, same time, and same weather.
Yep. The same amount of all the dry ingredients to the best of our ability, of course. Nothing is ever going to be the exact same amount, but the differences is not enough to impact greatly the outcome of our experiment. Just trying to get even, should be good. So,
This is citric acid, and this is baking soda.
yeah, in case the previous 4 trials were not clear enough.
I mean, I have specified.
Okay. So now we're going to take some of our room temperature water. So I actually tested this water out earlier, and I can tell you that it's lukewarm water, just by the pure fact of how much I hated drinking it. So.
You mean room temperature water?
Room temperature water, yes. Mix that up. Same type of reaction.
It seems that there's more foam compared to the cold water, but less compared to the boiling water. So somewhere in the middle.
Yeah, somewhere in the middle. There's no noticeable, obviously you cannot feel this, but there's almost no, or there's some precipitate there, actually.
How does the temperature feel? How does it feel?
It feels, if I'm being completely honest, all the temperatures feel pretty cold. They all feel the exact same. But I think the main difference that we're seeing here is the difference in volume. As you can see here, this is, it's definitely a lot more than the cold trials, but it's definitely not as much as our hot trials. I will put up a picture of some of the other trials right here just for comparison's sake, but yeah, I'd say it's a good in-between. You can definitely tell that there is more of a reaction happening here, but, not as much as the hot water. Again, I think that goes back to the fact that there's less energy with the cold and the room temperature water compared to the hot. So that means less energy going into the reaction, and therefore, producing less overall volume and carbon dioxide and things of that nature. So
I have a theory that I believe that the reaction actually consumes the energy or absorbs the energy, which is why the water or like the solution feels cold.
if it was becoming cold, it would be getting rid of energy.
Yeah, I agree.
But
I
we can cut
agree.
that out.
Yeah. This is the second trial of our control using room temperature water and mixing it with baking soda and citric acid. First, we're going to take 2 spoons of citric acid. Each spoon is 1/2 tablespoon.
Yeah, so that's 1 tablespoon for each one.
Yeah. And then we're going to use 2 spoons of baking soda, which is going to be 1 tablespoon.
Yeah, and of course these measurements aren't going to be perfectly accurate, but they're to the degree where I think the water is playing a bigger role here than anything else.
I agree. And now we're going to take 1 spoon of room temperature water. And of course I spilled water, but it's fine.
You are not him. You are not him. No. You are not him.
No, I'm not him. I'm just him.
No, you're an idiot.
And then we're gonna put the water, mix it in the bag. One thing I noticed is that there's less foam compared to other ones, except the cold one. And at some places it feels a lot colder compared to the sides of the foam. Actually, no, never mind, I take that back. It's the opposite, yeah. So places without foam feel warmer than places with foam.